So today we're going to cover Chapter 2, Section 6. It'll be the last section that we cover from Chapter 2. Today we're going to be combining or doing the combination of functions and then composite functions. So what we're going to be doing when we combine functions is we're either going to add them, subtract them, multiply, and divide them. So essentially what we're going to be doing when we add and subtract our functions, we're going to basically just be combining like terms. However, when you're subtracting the two functions, you might want to do sort of like a keep change flip and distribute the subtraction sign. When we're multiplying them, depending on the functions, and then when we divide, if you notice this exclusion over here, that the g of x function cannot equal 0, remember when we were doing the domain, we don't want a 0 in our denominator because it's going to make it undefined. So that's what that exclusion there is, that g of x function not equal to 0, because it would make it undefined. So let's try some examples. So notice up at the top, and I know it's kind of hard to see here in yellow, but these are our two functions that we're working with. We have the f of x function, which is equal to 2x plus 1, and the g of x function, which is that trinomial x squared plus 2x minus 1. And the first example wants us to add the f of x function and the g of x function. So essentially all we're doing is combining like terms when we add two functions together. So I'm going to go ahead and take my f of x function, which is the 2x plus 1, and I'm going to add that to the g of x function, which is the x squared plus 2x minus 1. So now I'm just going to go and look for my like terms. Notice I do not have any like terms here to combine with the x squared. So that one I'll just rewrite. And then I have a 2x and a 2x. So 2x plus 2x, I get 4x. And then notice the 1 minus 1, and that's 0. And I don't have to put plus 0 or minus 0. So that would be adding or combining the f of x function with the g of x function, where I'm using addition. Now, the example right next to it, since I've already combined the f and the g function, I'm going to take my combined answer, and now what they want me to do is take this value of 2, and they want me to plug it in for x. So I'm going to go ahead and take my combined function, the x squared plus 4x that I just solved in number 1, and now I'm going to replace all the x's with the number 2. So 2 squared plus 4 times 2, I get 4 plus 8, and I get 12. So f plus g, so combining the f of x function and adding it to the g of x function, when the value of x equals 2, I get 12. Then number 3, now they want us to subtract. Now, if I wouldn't have combined those ahead of time in number 1, I would have had to combine them first and then substitute in the value of 2. Now for number 3, they want me to subtract the two functions. And this is where I'm going to do maybe what you learned in middle school with your integers, your keep, change, flip, or your stay, change, change. So I'm going to write the f of x function down first. So what I'm really doing here is f of x minus the g of x function. So my f of x function was the 2x plus 1. And now I'm going to subtract the entire g of x function, x squared plus 2x minus 1. So here's where I'm going to do my keep, change, flip. I'm going to keep my f of x function the same. I'm going to change this subtraction sign to an addition sign, and then I'm going to flip or change all the signs in my second function, my g of x, to all opposite signs. So I'm going to change it to a negative x squared, a negative 2x, and then a positive 1. The other way you could think of this is think of this as a negative 1 here that you have to distribute into that second function. Now that I have set it up, now I'm just going to go back and look for my like terms. So notice there is nothing to combine with the x squared. So I'll go ahead and just write down the negative x squared. I'm going to go back and look for my x terms. And notice I have a 2x minus 2x, so that's gone. And then now I'm going to do the 1 plus 1, and I get positive 2. And that is my combined function of subtracting the f of x function and subtracting the g of x function. Now, they want me to do in number 4, they want me to subtract the functions, but then substitute in the value of 2 for x. And again, since I've already combined it, I'm going to take my combined function and then just plug in or substitute the value of 2 for each x. So again, I still would have been expected to have subtracted the f of x function minus the g of x, but since I already did it, let me take my combined function and now replace x with a positive 2. Remember, once you substitute in a value for x, you need to remember to follow order of operations. So I need to evaluate the exponent first. So I'm going to do the 2 squared and then drop down that negative sign. Again, you could think of this as like a negative 1 here that you'll multiply back later. And then negative 4 plus 2, and I get negative 2. So subtracting the f of x function from the g of x function when x equals 2 gives me a value of negative 2. So here, this dot in between here, this is telling me that I need to multiply my f of x function with my g of x. This time we've now changed the functions. So now my f of x function for these examples is x squared. And my g of x function is going to be x minus 3. So what I'm doing here is f of x times the g of x function. So I'll go ahead and write in my f of x function, which is x squared. And then my g of x function is the x minus 3. And now I have to distribute. I'm going to distribute the x squared to the x, which gives me x cubed. And then x squared times the 3, or the negative 3, gives me negative 3x squared. So this would be multiplying the f of x function with the g of x function. For number 6, they want me to now take my newly multiplied combined functions and now plug in x equals 4. So I'm going to take my newly combined function, the x cubed minus 3x squared, and replace x every place that I see it with the number 4. So let's go ahead and substitute it in. And again, you're following order of operations. So make sure that you do the exponent first, then we'll multiply, and then we'll subtract. So 4 to the 3rd power gives me 64. And then I'm going to evaluate 4 squared first, get 16. Then I'll multiply, and then I'll subtract. So try to do it in a nice, organized fashion. You don't want to try to skip any steps and try to rush through it. You tend to make simple, careless mistakes. And again, my functions have now changed again. Now, notice this time I'm adding in another part of the question. Not only do I want you to divide them, I also want you to give the domain. So we're going to cover domain for these combined functions. So let's go ahead first and divide them. So really what we're doing is we're dividing the f of x function by the g of x. So my f of x function this time is the square root of x. My g of x function is the square root of 4 minus x squared. This is my divided function. I'm not trying to simplify anything here. All I was expecting you to do is plug it in and set it up as a division problem. So now what we're going to do is find the domain. Now, we just took a test on this yesterday. Remember, when we're looking for the domain, we should always start out by thinking it's all real numbers, except when we have fractions and except when we have square roots. So remember, when it's a fraction, and let's just say it's not a square root in the bottom, we set it not equal to 0. But when it's a square root in the denominator, we don't want any imaginary solutions and we don't want it to equal 0, so we would set what's under that radical greater than 0. And for the numerator, whenever there's a square root, it'll be greater than or equal to 0. Because again, we do not want any imaginary numbers. So that's why it's going to be a positive number, and that's why we set it greater than or equal to 0. So let's first find the domain of just our f of x function. Let's go through and practice finding all of our domains. So let's look at the f of x function. And remember, that was the square root of x. So when we have a square root, we have to remember we don't want imaginaries. So we're going to take what's under the square root and we set it greater than or equal to 0. We're going to write this in interval notation. So if it helps you to give yourself a visual and put it on a number line, let's go ahead and do that. So we'll put 0 here. And we're going to go ahead and use a bracket for the greater than or equal to. And it's going to be all values greater than or equal to 0. So it's going to go from here to infinity. So in interval notation, the domain of the f of x function is going to be from 0 to infinity. Now let's go ahead and take a look at the g of x, just to practice this, because this was on the test yesterday. And then what we'll do is we're going to find the domain of the combined function. So for the g of x function, and just do it separately without the fraction first. So our g of x function was, remember, it was 4 minus x squared. So for this one, this is quadratic. So what we need to do is take what's under the radical, and I'm going to set it to be greater than or equal to 0. Now I know it's in the denominator, but let's just first find the domain of the g of x function the way it is. So remember, whenever you have a quadratic inequality, this is where we're going to place it on the number line and do our x check pattern. So I'm going to go ahead and solve for x, get x by itself. I could have also rearranged it and factored it, but I'm going to go ahead and use the square root method. And remember, whenever you do this, you get both positive and negative 2. So these are going to be the numbers that go on my number line, the negative 2 and the positive 2. So remember, when it's a quadratic inequality, we need to do a test point. So I'm going to go ahead and I'm going to plug in 0 for my x into my original here. 4 minus x squared greater than or equal to 0. And I'm going to plug in 0 and see if I get a true or false statement. This is a true statement. So this tells me that in the section where my test point is, it gets the check mark. And over here, these are going to be x's. So my domain for my g of x function is just the numbers in between negative 2 and positive 2. So here, 2 and negative 2. Now this is the g of x function as it is. But because it's in a denominator, when I go to do it for the combined function, I'm going to end up setting it just to be greater than 0. So this is just a little review of what we did on the test if these were two separate questions on the test yesterday. Finding the domain of just the g of x function individually and the f of x function individually. But now we need to find the combined functions domain. So what I need to do here is I'm going to go ahead and we've already done the f of x function, but I need to do the g of x function now as a denominator. Is find the domain of the combined function, which is the square root of x, 4 minus x squared. So this is my combined function when I'm dividing the two functions. So what I need to do is I need to find my domain of my denominator. And because it's a denominator, I don't want to set it greater than or equal to because it can't equal 0. So it's just going to be greater than 0. So then once I do this, the only difference from what I did before is it's going to be parentheses because it can't include 2 and negative 2. So I'm still doing the same thing here. And then and again, you solve it as if it's an equal sign to get those test points or the breaking points on your number line. So again, negative 2 and 2. And then we already plugged it in here. So we know this was the check mark, but because it's just the greater than symbol, this is where we're going to use parentheses. So the domain of the exclusions for the denominator are going to be from 2 to negative 2 to positive 2 with parentheses. Now, I also have to incorporate my domain of my original, which was here, of my numerator, sorry. So let's put both of them on the number line. So I have the 0, the negative 2, the positive 2. So we can already see that this one is here. That's this one. And then this one is going to be a bracket here going to infinity. Now, when we want to find the final domain of the combine function, I want to know where the intersection, where I see both red and blue. So my domain is actually going to be where I see both of these. So my domain of the combine function, so the f of g of x, its domain is going to be from bracket with a 0 to positive 2. So essentially, you need to do the domain of the numerator, domain of the denominator, and where the overlap is. And that'll be the domain of your combined. Yeah. So now they want us to do, and I know I've written all over here, so let me do number 8 over here to the side. This time, they want me to divide the g of x function by the f of x function. So remember, your g of x function is the 4 minus x squared. The f of x function is the square root of x. So that's the combined function. That's all you do. Put it into the fraction with the given functions. Now what we need to do is find the domain. And again, we're looking for the combined domains. So again, if we do it individually, so now my g of x function, since it's in the numerator, it's going to be like I had done originally. I'm setting this greater than or equal to 0 because my square root is in the numerator. It can equal 0. It just has to be greater than 0. So then when I solve it, which I already did before, but let's do it again. And then again, you're going to solve it as if it's an equal sign to get your test points or your breaking points on your number line. So negative 2, positive 2. We did the check over there. Remember, we got it to be true when we tested 0. So check mark here and here. So the domain of our numerator is going to be brackets with negative 2 to positive 2. Now for the denominator, we don't want it to equal 0. So what I'm going to do is take what's there and make it greater than 0. So that's why I'm not doing greater than or equal to. And then this on a number line or in interval notation would be 0 to infinity. And again, remember, infinities always get parentheses. So let's put both of these on a number line to give ourselves the visual. So negative 2, 0, positive 2. So the purple one, remember, were the brackets. And then the numerator, I'll do this one in red. So then this is going to be a parenthesis going to infinity. So again, the combined or what's in common to both is going to be this section right here where I see both red and purple. So again, I can't include 0. So the parenthesis is going to overtake that line. So my final domain, so the domain of my combined function, where g of x is divided by f of x, let me fix that and make it an f. My domain is going to be from 0 up to the 2, and the 2 gets a bracket. Because of the parentheses here, or again, you can think of this as an open circle, I can't include 0 because 0 makes my function undefined, my combined function. So notice this time, we've got this open circle here in between the 2 function letters. This is not a multiplication dot. It's indicating that we are composing these 2 functions. So the first one is read as f composed with g. So really what we're doing is we're taking this g of x function that they're going to give us, and we're going to plug that g of x function into the f of x function for the x values. And then this one is read as g composed with f. So we take the f of x function and we're going to plug it into the g of x function for every place that we see an x. So let's try some of these. Okay, so again, I'm giving you 2 functions up at the top. So again, that little circle in between the letters f and g, that is telling me that I'm trying to compose or take the g of x function, and I'm going to be plugging it in to the f of x function. So really what we're doing here is taking our f of x function, and instead of having an x in it, we're going to take out the x and replace it with the g of x function. So what we're really doing here is taking f and we're plugging in the g of x function into our f of x. So my f of x function, remember, is the x plus 2. So what I'm going to do is take out this x and replace it with the 4 minus x squared. So I'm going to take this out and in its place put in 4 minus x squared and then put in the plus 2. Combine your like terms. I have a 4 and a 2 that are like terms, so 6 minus x squared. And that will be my composite function of composing f with g. Now we're going to do the same thing, but we're going to switch the order. And we're going to plug in the f of x function into the g of x function on number 10. So I'm going to go ahead and really what I'm doing here is taking my g of x function, and every place that I see x in the g of x function, I'm going to replace it with the entire f of x function. So remember, my f of x function is the x plus 2. So let me go ahead and write down my g of x function. Remember, it was 4 minus x squared. So what we're doing is we're taking out the x and replacing it with the x plus 2. So once I replace, the 4 stays. I'm going to put parentheses here and replace x with x plus 2. Notice it's got still the exponent of 2 there. I'm going to need to apply that exponent and either FOIL or remember the pattern here for when you square a binomial. So really what I need to do here is this is going to become 4 minus, and then in here I'm doing x plus 2 times x plus 2. So I'm going to FOIL that or distribute it. So 4 minus, and then I get x squared minus 2x or plus 2x plus 2x plus 4. I'm now going to distribute, or think of this as being a -1 that you're going to distribute, or distribute the subtraction sign. So now I get 4 minus x squared, and these combine to be a 4x. So minus 4x and minus 4. Look for your like terms. 4 minus 4 is 0. So my final composed function is -x squared minus 4x. Next one, number 11, they want me to take this newly composed function, and now they want me to replace my x values with a -2. So I'm just going to take the answer I just got here to do number 11, the negative x squared minus 4x, and I'm going to replace every x with a negative 2. So place negative 2 here, and then a negative 2 here. And again, you're going to follow order of operations. So I'm going to evaluate this exponent first. So negative 2 squared becomes positive 4, but then the negative sign is still there. And then over here, I'll multiply negative 4 times negative 2. I get positive 8. And then now negative 4 plus 8. And my final answer is positive 4. We're still doing the same thing. Notice that circle in between that letters F and G. So I'm gonna, again, compose F with G. So again, here, I'm taking my G of X function, and I'm gonna plug it in to my F of X function. So I'm taking my G of X function, 4 times x squared plus 1, and I'm gonna plug it in to my F of X function. So let me go ahead and write down my F of X function. It's the 2x plus 5. And again, remember, you're taking out the letter x, and I'm going to replace it with 4x squared plus 1. So 2 times 4x squared plus 1, and then add the 5. I need to distribute the 2. 8x squared plus 2 plus 5. Combine your like terms. 8x squared plus 7. Let me go ahead and do the one right below it, because they want me to still take that same function and now plug in negative 1/2 for my x in my composed function. So let me go ahead and take my 8x squared plus 7. And now this time, I'm replacing x with negative 1/2. So let me go ahead and plug it in. Negative 1/2 squared plus 7. I'm going to go ahead and square, do the exponent first. Negative 1/2 times negative 1/2 gives me positive 1/4. I now need to multiply that with the 8. I get positive 2. Add it to the 7, and I get 9. All right, why don't you guys try number 13? Let's see if you can get the answer. Let's compose the G with F. So let's plug in our F of X function into the G of X function. Let's see if we can get the answer. Give you a minute here. See if you can get it set up. So again, we're taking the G of X function and we're plugging in the F of X function. And remember, your F of X function is the 2x plus 5. This one's going to produce a trinomial. Anybody getting an answer? Looks like Ethan's got the right answer here. Okay, it's 16x squared plus 80x plus 101. Very nice. All right, let me go ahead and work this out. He did it beautifully on his iPad. Now remember, when we do those class kicks, I can always see and then share it, but we're not in class kick today. So let me go ahead and finish working it out. So again, my G of X function, remember, is the 4x squared plus 1. So again, we're taking out the x and replacing it with the 2x plus 5. So 4 times, and then I'll replace 2x plus 5 squared plus 1. So again, we're following order of operations. So I need to square this binomial. So again, if you want to write it over here to the side, you can distribute or FOIL it, or remember the pattern for the binomial squared. Either way. So once I multiply this, 4x squared plus 10x plus 10x plus 25. So then now what I end up over here is it becomes 4x squared plus 20x when I combine the middle two terms, and then the plus 1. I need to distribute the 4, so this gives me 16x squared plus 80x plus 100, and then the plus 1. And then once you add that 1 in there, you get the 101. So when we're finding a composite functions domain, what we need to do first is find the domain of our input function. And then we have to find any other additional restrictions of the composite function. So not only are we looking at the final composed function, we also have to take into consideration our input function. So let's go ahead. So like in, for example, this one, what we're going to do is we're going to look at the combined function, but then we also have to look at the input function. So let's go ahead and try one. We have to compose it first. So for here, we're going to really take the f of x function and we're plugging in the g of x. So really what we're doing is taking our f of x function and plugging in the square root of 9 minus x squared. So I'm going to take my f of x function, which is the x squared minus 9. I'm taking out the x and replacing it with this. So let's go ahead and compose it. So I have 9 minus x squared under the radical squared minus 9. Remember, when you square a radical, it just cancels it. So this 9 minus x squared comes out. And now my combined function, 9 minus 9 is 0. So my final combined function is just negative x squared. Remember, when it's a parabola, when it's the x squared, is there any restrictions on that? On x squared or negative x squared? No. So the domain of this, of the combined, is all real numbers. However, we have to go back and look at our input function. Remember, our input function was the g of x. So if there's any restrictions on this, then this is going to be my final domain. So my domain of my input function, since it was 9 minus x squared, this is under a radical, so it's got to be greater than or equal to 0. Move the x squared. This is quadratic, so we got to do that test point. So again, we would solve it as if it's an equal sign. So plus and minus 3. So let's put that on the number line. Open circles here, or just put the two numbers, sorry. We got to do the x check thing. So let's plug in 0. So when I plug in 0 into 9 minus x squared greater than or equal to 0, I get 9 is greater than or equal to 0. This is true. So this gets a check mark. This gets an x. So the domain of my input is going to be brackets, -3, +3. So the domain of my final, since my final combined didn't have any restrictions, but my input function does, my final domain is just my input function. So the domain of the combined function is going to be -3 to +3. So in this case, the domain of the combined function is just the input domain, because the final one was all real numbers. Let's try one more. Let's combine this one. So f composed with g. So really what we're doing here is plugging in the g of x function for the x. So remember, your f of x function is the square root of x. So all I'm doing is taking x squared plus 4 and putting it under the radical here. So f composed with g is going to be the square root of x squared plus 4. So now, let's go ahead and my domain of my original, let's go ahead and do it both of these. So let's see the domain of the input. Remember, your input was the g of x, and it's x squared plus 4. No restrictions here. So this time my input is all real numbers. However, my combined function domain, it has a restriction. It's a radical. So it's x squared plus 4 greater than or equal to 0. But when we solve this, look what we get. We get an imaginary solution, plus or minus 2i. We don't exclude imaginaries, so my domain here is all real numbers. So the domain of the final combine, including the input, is still all real numbers, because I don't worry about excluding imaginaries. And that is it for 2-6.